In example 1, we need to simplify each expression. Notice that we can't solve these. They're expressions, they don't have an equal sign. So in this case, this one and this one, we won't be able to figure out what the variable is, but we can do our best job to simplify it. So let's look at A. There's actually no variables in A, so we're going to try to add these two fractions together. Notice how the denominators are not the same, so we need to multiply the left one by 5 over 5, and then the right fraction by 2 over 2. And I would put a little fraction bar there, but the negative sign is hanging out in the way. So we've got 5 over 10 minus 4 over 10. So this would be 1/10. And that is the simplest form of that expression. Part B, and you might argue whether this is simpler or not, but when we have this, when we're trying to add two things together, two terms I should say, we need to try to add those together if it says simplify. So we need to change this 1 into something that has a denominator of x. We can't change its value though. So here's what we need. We need to have a common denominator. And you might wonder to yourself, well, how in the heck would I figure this out? Well, if you take any number and divide it by itself, you get 1. So I hope you can see that this piece is the same. The 1, we need to change the way it looks so that we can perform this operation. 3 plus x is just 3 plus x. Can't combine those two terms, they're not like terms. And then we're going to write our denominator down. This is as far as you can take this one. Again, it's arguable whether this is simpler or not, but when you're asked to simplify an expression and you see a big old plus sign in here or minus sign, try to do that operation. So maybe a better instruction would be perform the indicated operation. With C, it looks like we could have a cancel party. Unfortunately, there are positives and negatives or plus and minus signs hanging out, so we can't do that. What we need to do is we need to factor this. So if we factor the top is factorable to x plus 1 times x plus 1. You could totally write that as x plus 1 quantity squared. So you could just put a little squared sign up there and get rid of the other one. The value wouldn't go anywhere. You'd just be rewriting it. But I think it's nice to write them out, especially when we're asked to simplify. And this is a perfect square trinomial right here. So 1 times 1 is 1. 1x plus 1x is 2x, and x times x is x squared. So you can always FOIL or distribute or however you were taught to do this to perform that multiplication, and you should get the trinomial here on the left hand side. X squared minus 1 is a difference of two squares, so we've got x plus 1 times x minus 1. And this works too. If you FOIL this back out or distribute this back out, you'll get the binomial here on the left hand side. And we've got an x plus 1 over x plus 1. We are allowed to cancel those out because those are factors and they're in common between the numerator and denominator. We are not allowed to cancel the x's here. We're not multiplying that by 1 and negative 1. We're just x plus 1 and x minus 1. So the best we can do for this one is x plus 1 over x minus 1. That's it. It is in fully simplified form. In part D over here, we've got y squared plus 9. That's not a difference of two squares. This was a difference of two squares. This one actually is not factorable. You might think it could be y plus 3 times y plus 3, but then you'd have a 6y hanging out in there, and we don't, so it's not factorable. Y plus 3 is already by itself as well. And so this one is already in simplest form. That's it. You can't simplify that any further. I know it's kind of tough, but sometimes you're given an example or a problem and it's just not simplifiable. You can't do anything with it. That one's good.